nobody wants a collision in space, right? Nobody wants to produce space debris that happens from that collision. And in space, people start getting antsy when you get within 10 kilometers of another object. On Earth, that seems pretty far away. But in space, given some of the different challenges with having confidence about where another object is, it becomes challenging at less than 10 kilometers, and we intend to get less than 1 kilometer from other spacecraft.
Welcome to the Emergent Podcast, where we interview product leaders from emerging technology companies about their work in the trenches to bring the hardest and most impactful technologies to life. Today's guest is Ari Rosner. Ari is a CalTech grad who began his career at NASA's Jet Propulsion Laboratory working on the Mars rover. Later, he founded and grew a COVID pandemic analytics product company, and then began deep tech venture investing with Riot Ventures, where he met the founders of True Anomaly. For the past 2 years, Ari has worked as the head of product at True Anomaly, joining as the second hire. In this episode, Ari and I discuss why we need satellites that can image each other and fly close together. We discuss the changes in the space industry that made it possible to build a constellation with such advanced capabilities in only 18 months for orders of magnitude less money. We talk about visualizing satellite motion in 3 dimensions as worms in space that can be used to keep spaceflight safe, and why this is so important for multi-step complex maneuvers. We learn how they cracked the nut of getting user feedback in an environment where most users won't talk about their work, how they earned sales long before their spacecraft were even in the sky, and the approach to hardware-software modularity and manufacturing that keeps True Anomaly nimble. Now a word from our sponsor. This episode is brought to you by Propel Auth. Startups and corporate innovation teams routinely waste months building core user authentication and authorization flows into their products. Propel Auth has automated all the most important pieces of the user management lifecycle. Instantly set up wait lists, magic links, social login, user impersonation, user management, role-based access control, SAML integrations for enterprise, team management, and much more. With Propel Auth, each of these challenges takes just a few lines of code instead of months of development and integration time. And with thoughtful control over design and skinning, it's easy to keep your product fully on brand. Get a generous free starter pack that scales through 1,000 monthly active users, or mention Emergent25 to receive 25% off for the first 6 months for more mature products. Get back to building your actual product and let Propel Auth handle your user management needs. Visit Propel Auth, that's PROPELAUTH.com to learn more. Welcome to the show, Ari.
Thanks, Adam. Great to be here.
Awesome. Well, let's jump in. This is a super fascinating topic, satellites that are looking after each other. So let's start a little bit zoomed out. What big picture challenges is True Anomaly designed to solve? And at a high level, how is the company approaching that solution?
Yeah, great question. So True Anomaly was founded to tackle some of the most pressing challenges in the space domain. And we're specifically focusing on space sustainability and space security. Space, as everyone knows, is critical to almost everybody's everyday lives, right? Communication, navigation, and just general security. So the origins of True Anomaly, we were founded out of pure need, right? The 4 co-founders of True Anomaly were at the forefront of space security, as members of the U.S. Air Force and the U.S. Space Force, and they watched as our adversaries' capabilities rapidly developed. They saw large gaps in often dated software and hardware that they had at their disposal, and saw that the current defense industrial base couldn't meet those needs. So, from a product standpoint, the depth of experience of our team kind of helps us make sure that we're developing the right products, and that we're not really just building innovative products, we're building innovative products that are also grounded in those real user needs. So at the end of the day, the solution is kind of, 2 pieces, right? So there is a full stack platform that we're developing that is the combination of hardware and software. So on the software side, we're building Mosaic. That's our advanced training, simulation, command and control software, basically everything you need to plan, analyze, and fly out a satellite mission. And then we have Jackal, which is our autonomous orbital vehicle. It's a highly capable spacecraft. Whenever you build the spacecraft, there's kind of the second step as well, is actually building out the manufacturing infrastructure to make sure that you can scale production and also rapidly iterate on capabilities. So that's kind of part one. And then when we think about it from a product standpoint, part two is our design mantra, right? Which is designed from a theory of victory. So we don't just build hardware and software for the sake of building it, or because we can. We take a step back, and in a product development cycle, we say, what does victory for the U.S. and its allies look like, and what combination of hardware and software can actually get us there? And we do countless, user research interviews. We do countless simulations of different architectures, capabilities, and what would happen. What if scenarios back and forth, and then we go and build the solution that will win. So that's kind of what we're doing and how we build it.
Can you give an example or two of what it would mean to be responsive to a space security challenge? For a lot of people who aren't in space, they're kind of wondering what's going on. They know that China and Russia and other countries have programs, but what is it that's going on out there that we might need to be responsive to?
So a lot of our critical infrastructure, right? We think about, our GPS is there, a lot of, defense infrastructure in terms of having satellites that take pictures, and you see that, in the newspaper every day, and being able to understand what's going on around the world. A lot of communications infrastructure, a lot of TV, and you see the proliferation of a lot more communications infrastructure. So in the time of a conflict, those would definitely be infrastructure that would be under threat. So being able to make sure that we can protect and defend and service and support those assets is an example. So there's a lot of different hardware up there that we want to be able to go and be able to support. And you then need the software to kind of help you understand how best to support it.
Okay. And just to clarify, one of the things that the constellation and software can do is take a satellite and take a picture of another satellite or go get nearby to go inspect something. Is that correct?
Exactly. Yep. That's exactly it.
Okay. And so, what are some of the technological advancements in hardware or software that are making it possible for a commercial entity to build a constellation that does this type of work? Because this hasn't existed before, has it?
Yeah, that's exactly. It hasn't existed. It's very new, and I think the first thing that everybody's probably pretty aware of in the news is the massive drop in launch costs. Right, it's much easier to get to space right now. It's much cheaper. There's a lot more opportunities because of the number of providers, and it's just become less expensive to get there, which makes it much faster in the first place. You have more opportunities to get on orbit, test your hardware, and iterate on it quickly. Right, we can launch multiple times a year, where previously that was unheard of. The second big advancement is on the software side, right? Most ground software that is being used, is built with a coding language that's older than both of us. It's using Fortran, which is 67 years old. I had to look that one up. So it's actually older than the internet, which means that it's not designed for a lot of these large network systems. So more recently, software has kind of come available that is designed for fault tolerance and network systems and parallel processing, and that's what we're kind of building our software mosaic in. And the last is, the individual components in the space market. They've dropped significantly in price and become a lot more available, right? 10, 20 years ago, it was really hard to get space grade components, your solar panels, comm systems, reaction wheels, all these different components. And they're really expensive because not many people were flying that many satellites. But now, due to economies of scale and the commoditization of these products, it's a lot more easy, or it's a lot easier to get these components, and it's a lot less expensive. So that helps us get up, and innovate much faster.
So on the hardware side, I totally get that, being able to buy a reaction wheel or a solar panel straight off the market and know that it'll actually work on your satellite. On the software side, to what extent do you guys find that you're having to build brand new paradigms, train your own models? Where are you able to actually leverage existing technology there to leapfrog a little bit faster?
Yeah, that's a good question. The physics itself hasn't changed, right? The physics of how satellites orbit, has pretty much stayed the same, or our understanding of it has stayed the same for quite some time. There are some nuances and some improvements and algorithms that we've used, but in many cases you can leverage that as kind of a starting point. But on the software side, we've started from almost a clean slate, which has kind of given us that advantage. A lot of older companies, you have your millions of lines of code written in Fortran, and it is very painful to kind of start transitioning to a newer language and being able to do that. So we've had the luxury, I'd say, in many cases, of starting from a blank slate, so we can build a lot of things from scratch, take lessons learned from people who built it before, and then go and build it better.
And what are some of the product challenges that are unique to building? A lot of people are building satellites. That's already really difficult and challenging for most people to think about. But for satellites that are specifically taking pictures of other satellites in space, what are some of the unique challenges that have come up breaking ground in that field?
Yeah, the number one priority when taking pictures of satellites is safety, right? When you're conducting these RPOs, rendezvous and proximity operations, safety was the number one priority. So for some context, right, an RPO, rendezvous and proximity operation, is a set of maneuvers that a spacecraft would perform when they approach another satellite, right? That could include refueling, resupplying space stations, inspecting debris, or inspecting other spacecraft. And it is incredibly challenging. And True Anomaly intends to perform RPO to image other spacecraft and other space objects. And the number one priority is, nobody wants a collision in space, right? Nobody wants to produce space debris that happens from that collision. And in space, what's really interesting is people start getting antsy, when you get within 10 kilometers of another object, right? On Earth, that seems pretty far away. But in space, given some of the different challenges with having confidence about where another object is, it becomes a little bit more, challenging at less than 10 kilometers, and we intend to get less than 1 kilometer from other spacecraft. So there's a lot of different things that we've built from a product standpoint into especially our hardware and our software to be able to do that. So one of my favorites is actually something we built as a visualization of Mosaic. We built it to support our guidance, navigation, and control, or GNC team. And it kind of helps you visualize the uncertainty of your mission plan. So you can kind of imagine the location of a satellite. It's not a fixed point in space. It's a probability distribution of where you think it is. That's based on the sensors you have looking at it. And as you maneuver over time, that bubble, that probability distribution is going to shrink and grow based on a number of different factors, whether it's the maneuver that you do, the sensors you have looking at it, and just the knowledge you have of where you are. And that distribution over time will turn into kind of a tube or a worm, right? You can imagine that kind of bubble shifting over time as it follows your trajectory. That the math is very complex but very interesting. So what we've built into Mosaic is the ability to visualize that worm every time you plan a mission. And what's really novel is that that's traditionally done either not done at all, or it's just shown as a matrix of numbers, and that's not very intuitive or helpful for an operator to understand the risks associated with their mission. So every single time you plan a mission to Mosaic, you will see that worm, and it will show you exactly the probability distribution of you getting too close to another satellite. But let's take that one step further, right? So when you plan your maneuver, there's a chance that something doesn't go right. So let's say your RPO has 5 maneuvers in it, and for some anomalous reason, the fourth doesn't happen, right? A thruster only fired half as long as it was supposed to, or some other random thing happened. That could mean that you could collide with another satellite, right? If you were intended to fly around that satellite and that maneuver didn't happen, that could be dangerous. So what we can even do with that tube is even look at every single possible permutation of how something could go wrong, whether it's a thruster fires for half as long or full as long as it's supposed to, and then simulate that and visualize that to a user so they can understand for their mission plan exactly what could happen in every single possible outcome. And this is what you need to be able to fly a satellite safely. So that's what we do.
Yeah, this is really fascinating. I've been really excited over the past couple of years how space companies are thinking about ways to abstract some of the challenges that astrodynamicists are focused on. Like you said, just kind of looking at those numbers. And I love it. I love a great astrodynamicist, but we can fly more spacecraft if we don't need as many of them. So I guess one of the other questions that this raises for me is, are there other ways that you've had to consider the user experience when you're thinking about these extremely complex sets of numbers that might be, coming off of different sensors that are going to help you plan your mission? What are some of those other things that you guys have had to consider?
Yeah, visualizing in 3D space is really hard because it's just different. The way satellites orbit around each other is not necessarily intuitive unless, like you said, you're an astrodynamicist or have years of experience flying satellites, which luckily we have a lot of those people on our team. But being able to visualize it in different ways, whether it's different reference frames or being able to orient yourself to the environment as quickly as possible, is super important. So when building, especially in Mosaic, we've been able to add in a lot of different views, and that's because we're leveraging some pretty powerful 3D engines to be able to go and enable a user to orient themselves much faster and then make better decisions. On top of that, when you take that 3D view and start overlaying more and more information on top of it, it makes it more intuitive as opposed to right now, typical operators will have multiple different computers with different sources of information. So we try and pull it all together, synthesize the information, and then display it in a single view. So it's less overwhelming. The fewer places that you have to look, the easier it is to make a decision. And if it's all in the same place, that information, it's much easier.
More and more cutting edge companies are building at the intersection of hardware and software. At least that's something that I'm noticing. What are some of the unique challenges that's introduced at True Anomaly, and what does the team learn from those experiences?
Yeah, it is a really interesting experience. On the software side, there's well-defined agile project development processes that I think a lot of people are very experienced with. There's lots of books. Your blog's a great resource as well, Adam. And these allow for rapid iteration and adjustment to requirements, and rapid user feedback, and that's really great. But on the other hand, aerospace for the last 50 years has been using let's say, different development process that's largely influenced by these large systems integrators, and it tends to be quite a bit slower. And it's kind of more waterfall oriented in a way. And that works all right when you're a massive multi-billion-dollar company. But in many cases, it leads to delivery of hardware that is, years behind schedule, underperforming, overpriced, and has a lot of issues with it. And this is exactly why True Anomaly exists, because those large system integrators can't deliver in a way that meets current and future needs. So just to kind of dive a bit deeper into that current development timeline, and just to make it clear exactly how long it takes, usually a large company will wait for an RFI or an RFP, right? These are the proposals that come out from the government saying, here's what we want. And typically there's a few years of studies into what the problem and solution is going into that. Then after that RFP comes out, these large companies start bidding on it. They start, there's a down selection process. There's a few months more discussing, refining the thesis, and then a few more months of contracting. And only then do you actually start the design process. Then you go through numerous review cycles with the government, order your hardware, build it, test it, and then fly it typically 10 years later. And that's assuming the program's on time. Throw in a couple of congressional funding challenges like have been in the news recently, and you can imagine that makes the timeline speed up to, or take as long as 15 years. And at that point, the technology could be obsolete. So, we've been working really hard at True Anomaly to bridge the gap between hardware development and software development, and the way that the processes that are used to develop them. And it's a big challenge. It's something we continue to iterate on here at True Anomaly. And we've developed a number of different agile processes to make sure that hardware and software are in lockstep. And that means you need to iterate oftentimes much faster than the government can put out requirements, right? You need to be able to anticipate the need. That's through that user research that our product team's doing. That's also through having our own users internal to the company, and having unique insights into those challenges to be able to go and do the research, do the design and development, such that we have a product ready by the time the government surfaces this user need. So that's kind of how we can move really fast, both on the hardware and software side.
So I'm going to ask you a loaded question here. For a lot of people who are following along, there's kind of a dirty word in product management, which is program management, but it's a word that you can't escape in a company that builds hardware. And I would just be curious, how do you distinguish in your role between program management and product management, especially in the hardware software blended capacity?
That's a good question. So we have a program team here at True Anomaly, just in addition to our product team, and we work really closely together. Program really helps us manage the requirements the government has. They levy on you. You need to meet X requirement. You need to meet Y requirement. Product really works closely with program to figure out how we're actually going to go and do that. The implementation. You need to build a software to do X. We then figure out how we're actually going to go and build it, work with the engineering team to build it alongside the program team, and then deliver that to the customer. So it's hand in hand. We make sure that the program team and product team are well aligned, and that allows us to move really quickly and build to meet the government's intent, but build the optimal solution. And for an example for us, right, is that we're building both hardware and software. Well, if you need to meet a certain camera capability requirement for your satellite, you could potentially meet it on the hardware side or the software side, depending on how you want it to go, and use certain algorithms to go and do, let's say, image recognition. So the program team kind of helps us understand those requirements, and then we go and work with the engineers and the end users to figure out how we actually want to go and solve the problem.
This episode is brought to you by Tonic AI. Tonic intelligently transforms your sensitive production data into realistic test data that's safe to use across your lower environments to accelerate your engineering velocity while safeguarding data privacy. We've all experienced the pain and wasted cost of building features with unrealistic data in staging or development environments. Mismatches between prod and test data lead to costly bugs in production, poor user experience, and when it comes to RAG or LLM applications, even incorrect answers. Moreover, as the data scale increases, it becomes difficult for developers to test their features with high fidelity. Tonic's products streamline data synthesis, subsetting, and provisioning to get developers the realistic data they need when and where they need it. Get on-demand access to safe, high-fidelity versions of your structured, semi-structured, or free text data to shorten sprints, catch more bugs, and ship better products faster. Visit tonic.ai/emergent to learn more and receive 15% off in your first year. And then one of the things that I know we've talked about in the past, and you kind of mentioned in passing, is that your founders are users of your product. But you guys also have a really interesting challenge, I think comes up a lot, especially in technologies that can be leveraged for national security, which is there aren't that many total users out there to just, walk up to and do research with. Like, how have you guys tackled that challenge inside True Anomaly to make sure they're still getting as much signal from the market as possible?
Yeah, we have kind of two different iteration cycles, right? The first is the internal iteration cycle. We have our founders who are former Space Force operators, and we have our own space operations team. And they also, in many cases, are former operators. So we can iterate on a daily or weekly cycle, get their feedback, do user research, make a mock up and say, hey, what do you think of this? And just quickly iterate on that. That then means that by the time we go to these external stakeholders and do those user interviews and show them these mockups, they've already gone through multiple cycles of iteration. So we're best utilizing their time, and we're able to kind of show them something that is, in many cases, a 90% solution as opposed to a 10% solution, and then iterating it on it there. So you're right, there's not a ton of end users. The Space Force is a very young organization, but they're rapidly iterating and are very understanding of. They have a very good understanding of what their problems are. So they're really helpful when you do user interviews, as they really are excited to shape those solutions.
Yeah, interesting. So the insight is basically that you actually have to elevate what you're going to show to them to a high enough level so that you sort of have permission to walk into that room where otherwise a normal startup would have no business even getting that meeting in the first place.
Exactly, and it gains you a lot of credibility when you can walk into the room and already understand their problems, right? That everybody, whether it's the Space Force or any other user, is really going to appreciate that when you walk into the room and say, "Hey, I understand that you have this problem. These are your key pain points. Here's a proposed solution. What do you think?" As opposed to, in many cases, when you do your user interviews, you start by saying, "Hey, what are your problems?" And in many cases, it's such an open-ended question, or people have spent so long talking about their problems, they really want to talk about solutions. That's what gets people excited. So it gains you a lot of credibility when you walk into the room with that.
Yeah, it's one of those funny things where, every product person wants to walk into the room and start with, let's talk about your problems, let's see what your workflow is end to end. And there's certainly a place for that. But in these high stakes environments, it can be difficult to earn the trust that's needed right off the bat if those are what your starting questions have to be. So you sort of have to elevate it a bit above that.
Yep.
Very cool insight. So one of the things that makes me most excited about having this conversation is that hardware product development is as old as the Industrial Revolution, and it hasn't changed too much, as you've already mentioned. But yet, you guys built 2 satellites in about 18 months that are now on orbit, which is pretty mind blowing. How did True Anomaly? How did it do things so fast? Right? Like, how did you guys achieve that level of disruptive impact in such a sort of old, stodgy industry?
Yeah, the Industrial Revolution is actually a really interesting analogy because you look at the advent of the production line, the automotive production line in many cases, and that really spurred a lot of rapid development. And that's something we've taken iteration from automotive design, right? Car makers deliver and iterate on new cars every year. You have your 2024 model year, your 2025 model year, and so on. And we do the same thing, right? We deliver new capabilities every year. We test them rapidly and iterate. So our factory is a production line. And as you move along those lines, firstly, that helps us build much faster and at a much lower cost. But secondly, we can then iterate and add new capabilities to the production line as we're building, so that each successive satellite could have a markedly different chassis, or a better camera, or other sorts of improvements. So we can then again, with the decreased launch cost, we can go and fly it really quickly, learn, and then iterate and add that into the production line as well. So our production line was purposefully designed in a way that we can add more capabilities in as we're going, and then we have all of our testing facilities in house, which also speeds up the testing process as well.
Were there major implications here for how much you guys build in house versus how much you procure externally?
Yeah, there's a lot of different trades there, right? And basically, component by component for the satellite, we did a trade study, right? We made a slide deck of here's what it would take to go and build it in house, and here's all the things that exist in the commercial market. And in many cases, some of the components that we needed didn't exist, so it kind of forced our hand to go and build it. In many cases, there were really good flight proven, components that had flown hundreds of times before, had a lot of flight heritage, had a price and a capability that was consistent with what we needed. So there's no reason to reinvent the wheel there. So basically, component by component, we did a trade study, a build buy trade essentially, and that's how we came across it.
And did people pretty much respect those decisions? Because I've met some of your colleagues, and they are fantastically brilliant. And I know that the more brilliant the engineer, the less likely they are to want to take somebody else's off the shelf thing. So just curious, was that a hard sell internally?
Yeah, the more smart people you have in the room, the more opinions you're going to get, which is a great problem to have. But it means that when we put together those slide packages, there were definitely certain components that we disagreed on. Somebody would say we should go build it in house, versus another person would say, uh, we should go and buy it. And that's where product comes in to an extent. We can kind of help understand the ROI, right? What are the trades in terms of bringing in finance and understanding the costs of being able to build it in house. Understanding is this the marginal improvement of let's say your in-house component versus an external component, is that something that would resonate with the customer, and we can kind of help kind of provide guidance on those trades. At the end of the day, it's the engineers making the decisions, but we can help them make those decisions better.
Fantastic. So, common problem I see for hard tech companies is that the product isn't ready for a really long time. So, you're in an R&D mode for this prolonged period of sometimes years, but you still need to be able to sell the product, especially as a venture-backed company, in order to get the traction you need. And you guys have had a really successful fundraising round, or sorry, a series of fundraising rounds, but also the technological progress to back that up. And I'm just curious, like, how did you guys approach pre-selling the product when you couldn't give the customer, the outcome early on?
So I think it starts, with your requirements actually a step before that, right? So given, as we talked about, the fact that our founders and many of the, our team is former end users, we're able to set a strong set of requirements. And then we continue to get user input. So that meant that, what we were building was very much what the customers were telling us they wanted, and what the end users were telling us they wanted. And for software, we constantly iterate. We do demos to different customers and get rapid feedback, and that's pretty standard from a software standpoint. On the hardware standpoint, for Jackal, our autonomous orbital vehicle, some of the pre-selling we've done is soliciting test plan inputs from potential customers who are interested in how Jackal can meet their needs. We also have customers asking to use Jackal for training exercises to help them understand how they could use it better. And in these cases, Jackal as our flagship product is doing what it's supposed to be doing, selling itself through its capabilities and getting customers excited, and does that really well. But I think at the end of the day, we're not just a satellite company. We deliver integrated hardware and software solutions, and we also deliver standalone software. So there's a lot of pre-selling that we're trying to do on the hardware side. And that validates what we're building, but we're also building software, and we've already delivered that to government customers, and they're already using it. So we're iterating on that as well. So that kind of helps, especially when you talk about, being a venture-backed company that needs to generate revenue. The software kind of helps you get to that much faster, get to that product market fit, prove it out, and then you layer in the additional capability of the hardware, and combined with the strong understanding of user needs and requirements, could build a product that users really love.
Yeah, that's fascinating. So you've broken down both sides of the coin, and then you show as much as you possibly can. Is there anything from the hardware side that you were able to demonstrate before launch that was exciting to buyers? And what did that look like?
You can do a lot of simulations on the hardware side. You could simulate what your capabilities can look like, and we can again use Mosaic for that. You can have somebody practice flying out a mission with a simulated Jackal using our software. We also have a hardware in the loop, software in the loop. So Hill which is basically it's a 1-to-1 of the satellite, but it lives on the ground, and you can fly out missions with realistic components, spinning up, and it uses all of the same as our flight components, and that allows them to practice flying out Jackal on the ground. It's also used by our space operations team for testing. So that's useful. We also do synthetic imagery, right? We can simulate what the image will look like from a Jackal based on the cameras that we have. So you can show a customer, here is an example of what the imagery that you will get looks like before the asset's even on orbit.
I love that. A lot of people think that hardware companies and software hybrid companies like yours can't really be responsive to the market, especially on the timelines that you guys are delivering. But I'm really excited to hear a little bit about how the strategy for building the product has actually evolved in response to customer needs or your company's evolving understanding of them. Could you comment on some of those examples?
Yeah, there's a lot of emerging customer needs. I think that's there's no shortage of that. So actually, from a product standpoint, it's really working to prioritize those, right? Triage them, understand what's a need that is right now, but also what's a future need. How can we combine them together? In many cases, there's a lot of end users that have shared needs, right? So product can work to identify, what are the big rocks that we can, use one rock to kind of hit a lot of different birds. So that's definitely been an interesting challenge, being able to prioritize. It's also that there's kind of the second layer of just because a user's, has all these emerging needs, there needs to be budget backing it, right? And that's obviously one of the complexities of working with the government is understanding where there's money to go and actually put towards solving the problems and emerging needs that are coming up. Because oftentimes, government funding trails a few years behind the identification of those user needs. So being able to kind of pair those two things together is really important in developing our product roadmap. So yeah, our product roadmap changes a lot. And that's, I think, totally okay. I think it means that we are responsive to user needs and user feedback. And I think that's great.
I'd love to zoom in on one of those needs where you had to make a hard trade-off decision, just so everybody can get an idea of like the types of things that you have to say no to or then say yes to, in a challenge as specific as this.
Well, I'd say firstly, I don't like to say no to anything. I like to say, "Oh, well, add that to the backlog." That's my typical product response. Is we're not necessarily going to say no to user need because if there's a need, we should be building a product to go and solve it. But being able to just say, "Yep, we'll add that to the backlog," if it's not necessarily something that is in line with our current roadmap or in line with where there's money, is something that we've definitely done a lot of. But I don't like to say no to anything.
You have a very diverse role. You're involved in setting up fabrication. I've seen you build CAD drawings, be deeply involved in technical specs, customer meetings. Obviously, you're a talented person, but there's still a limited amount of time each day. As a person leading product in a complex emerging technology hardware software hybrid company, how do you decide which of these activities to actually prioritize and spend your time on versus other things?
Yeah, that's a really good question because in an ideal world, you get to do all those things. And back when you're a 6-person startup working out of a small room, you need to wear all those hats. But then as you grow to a 130 plus person company, you need to be a lot more judicious with your time. So the two places I try and spend most of my time is talking to engineers and talking to customers. Because at the end of the day, if the engineers understand what the customer wants and the customer understands what the engineers are building, you're probably building the right thing. But like you said, back when True Anomaly first started, I tried to do everything. The early days were actually pretty fun. There's a fun story that my roommate and I both worked at True Anomaly, and during the day we would do go to the office and do our normal jobs. I would call it, where I was doing product and he was a propulsion engineer. And then at night, we'd go back to our apartment and we'd sit on the couch and plug in my computer to a projector and go and put the CAD up on the wall and basically go and iterate it on the spacecraft. And then we'd come in the next day and show it to the team, our production and our spacecraft team, and we get feedback on it. And then the next night we'd go and iterate on it. And so we'd work all night on the CAD model, and then in the day we'd do our day jobs. So definitely a lot of different hats, and it was a really fun cycle. Like that was honestly some of my favorite memories. Yeah. So early on, like you said, I was doing developing the CAD for the spacecraft, doing customer demos. I worked on our financial model at one point, and a bunch of other random things. But I think as a product person, I think that experience is super valuable because product connects every single part of the company. So being able to understand intimately all those different aspects is crucial. So I love it. But yeah, right now I try and spend most of my time talking to customers and engineers.
It's fascinating because a lot of companies will produce prototypes that they show to customers over and over again in order to refine the ideas. But what you just called out is a really interesting insight, which is that inside emerging tech, hard tech company, you're doing that iteration with the customer, but you're also doing that iteration internally to assess the feasibility of the spacecraft, right? So you're making a drawing and you're saying this is how the components are going to fit together. And then you go to the head of flight operations and they're like, nope, that's not right. Is that about what's happening?
Yeah, there's so many different stakeholders between the actual operators, the engineers, manufacturing, right? Designing for manufacturability from the start as opposed to building something and then having to figure out how you manufacture it. So we tried to kind of front load a lot of that. So the design process was super iterative where there were so many different stakeholders. And I actually distinctly remember one day, I went to dinner with somebody from our production team and, we started sketching out on a napkin a couple different ideas. I catted it up that night on my projector wall and then came in the next morning and had, I think, all 6 or 7 stakeholders in a room and pulled it up. And it was a big aha moment where we're like, that actually works. And that meets your requirements and your requirements and your requirements. And we ended up, patenting that design and it was pretty incredible. But yeah, there's a lot of iteration cycles and then you get that nice aha moment. And I definitely remember that one.
Can you tell us about a time when the team's judgment on product wasn't correct and how you guys discovered it?
Yeah, it's a really good question. Product judgment's interesting. As a new company, you kind of have the luxury and the challenge of starting with a blank slate for your product roadmap. And as we mentioned, we're fortunate to have co-founders who, were end users and that have kind of helped us identify those key pain points. So our product backlog is a very, very long product backlog. So early on, we would kind of take pieces out of the backlog and kind of chase demos, right? We would go and try and rapidly prototype a capability, stick it in front of a customer and be like, what do you think? And, as an early stage company, rapidly developing products and getting them in front of customers is honestly a good thing, right? Because, demos lead to customer interest and customer interest leads to revenue and all that's really good stuff. But on the product side, we probably needed to establish kind of a cleaner, clearer roadmap to then ensure that when we were kind of deviating slightly to do these demos, they were still constructive to the overall roadmap. And I think that's kind of where judgment comes in, right? And being able to develop, for those demos. So we learned that lesson really quickly, but it was a very important lesson to learn. So we still build stuff for demos, but we just make sure that again we're pulling in capabilities from the backlog for those demos that are consistent with where we're already going for the roadmap and kind of meet these customer needs and then help them understand what the vision is for that capability as opposed to deviating pretty significantly from that roadmap.
So the things that you demonstrated, they were always needed. You didn't have one where you demonstrated something and they were like, we don't really need that thing because it was always something they had asked for, or were there some things that you guys actually ended up discarding in the process?
Totally things that we discard, right? Or in many cases, it was just we were showing a capability to a customer that they didn't personally care about, but maybe some other person cared about. So that again goes back to stakeholder mapping and understanding the user journey and understanding the user, right? Because we can anticipate what we think that customer is going to need based on their job description and their role and their previous experiences. But then you stick a product in front of them and you're like, actually, I don't really care about that. So that then helps refine our, our user journey. It helps to define our personas, right? Our persona models. But yeah, those are also super useful lessons learned. So I wouldn't say there's ever been something that we've completely discarded, but there's definitely been times where a user has said, that's not quite what I personally need. And that's helped, map our personas.
What are some examples of things that you now understand about the customer that you didn't understand 2 years ago? Like, what are some of those insights?
Ooh, there's a lot of interesting pain points that we've started to understand. I think the first is how sensitive the customer is to vendor lock. I think that's one of the biggest concerns that the government has. They've been burned on it multiple times. So for context, people who are not familiar with vendor lock, it's something that traditionally these large companies will do that will make it hard for their system to become interoperable with other systems. And it also makes it really painful to swap away from their system. So the government's kind of locked into that vendor and can't swap away very easily. And through a lot of really early conversations with customers, that was one of the biggest things is that they're super excited about a new player entering their field, but having it where everything can interact with every other piece is really important. So when we designed Jackal and Mosaic, they're both incredibly modular and interoperable from the start. And that's because we were able to design that architecture from day one based on that user feedback. So on the software side, for example, the backend physics can be removed, or the front end user interface can be swapped out. So it's modular in that way, and it helps really reassure customers that they're not being locked into anything that they don't want. And then we end up, from a product side, we got to build better products to make sure the customer doesn't want to go away or swap to something else. So the onus is kind of on us to make sure that we are continually iterating and developing and building stuff that they want so that they don't leave.
It's a pattern I see a lot in companies, especially that have at least some of their sales on the government side. But I also frequently see the government not actually taking advantage of those options. Like they want those options in order to know that they'll be safe if they change their mind. But then in fact, the best value is still delivered with them. all combined together. Have you guys found that, or did you actually find that they took you up on some of those arrangements where you pull this part out or leave that part in?
We're still very early in the process, so I think it's definitely something that we're still learning. I would say that it does seem like they want to be able to interoperate. Now, we haven't been, True Anomaly is a 2-year-old company, so we haven't been around long enough for us to go and unseat or be unseated in any significant way. But I think that'll be really interesting to track over the next few years is how useful the modularity ends up being. I think it's one of those things where people like the illusion of choice. I think it's something that the government will definitely use, and I think there's a lot of cool ways you can do it. And I think more than anything, it's just making sure that there's easy data pipelines, easy APIs that connect all the pieces together to make it such that when the government wants to onboard a new capability from another person, it connects seamlessly with ours, as opposed to right now, they literally have like 4 different computers that have run 4 different software that don't talk to each other. And in many cases have to burn something onto a CD or a floppy disk to go and communicate between them.
So what comes next for True Anomaly, and what are some of the riskiest value propositions that you guys need to stress test next?
Yeah, what comes next? We have another launch and flight test coming up in late 24, and we plan to iterate really quickly on both the spacecraft and the software. And this is honestly, the proof is in the pudding. We're going to prove the hypothesis that we can iterate quickly and take in those automotive-like production capabilities and deliver solutions on that relevant timeline. In terms of what's risky, I think the most interesting one is as we start to roll in more and more autonomy. Right, we've taken a crawl, walk, run approach to starting to layering in intelligent algorithms to speed up stuff like mission planning and decision making, and help operators make better, faster decisions. This gets back to the OODA loop. The observe, orient, decide, and act. If you can help somebody close that OODA loop faster, right, help them observe, orient, decide, and act better and faster, they will win, right? And that kind of ties back to the design from theory of victory. But there's also risk when trying to automate something that's been a manual process for as long as it's really been a process, right? You can't make that automation a black box where you just press a button and it spits out a decision, because an operator is then going to be like, why did that make that decision? And if you abstract away too much information, they may not feel comfortable with that decision or they won't use it. So I think one of the riskiest things is figuring out how to strike a balance between automation and the information we provide, and automating the correct things to enable the human machine teaming, to be as optimal as possible. So that's gonna be really exciting. I think there's a lot of really cool user research we're gonna do there. And that's how we're gonna stress test it, right? Talking to operators, prototypes, mock-ups, journey mapping. And we're lucky, like I said, because our users are internal, right? So we can, have daily or weekly feedback from internal users before we even take it to an external user. So it's a lot of fun, with that luxury of having so many different operators at your disposal.
More autonomy makes sense, but also with a human in the loop at the right moments in time. So if the audience or potential customers or VCs or others want to get in touch with you guys, how should they reach out?
LinkedIn's a great platform for that. Or always just shoot me an email. My email is ari@trueanomaly.space. So feel free to drop me a line.
Fantastic. Thanks so much for taking the time with us today. Really appreciate it. Ari, have a great day. Thank you.
Thanks, Adam. You too.
Thank you so much for listening. Emergent is brought to you by First Principles, where we provide emerging technology product coaching and fractional product leadership to founders with bold visions. If you found this valuable, you can subscribe on Spotify, Apple, or wherever you get your podcasts. Please consider leaving a review or sharing feedback directly with us. You can always find previous episodes, show notes, and more content on www.emergentproduct.com.